So we're going to combine a couple of concepts here. We're going to talk about percent increase and percent decrease and also percent error in all of these. So let's just do a quick kind of look at percents. So when we talk about percents, go back to the candy bar. So if we have a Hershey's candy bar right here, that's one whole candy bar. So this is the whole thing. But as we know with Hershey candy bars, you can divide them up. So let's just say we divide it up into 5 pieces. If I have these 2 parts right here, I have 2 parts out of the entire whole. Okay? So we want to always do part over whole. Well, how much of a part do I have? I have 2 out of 1, 2, 3, 4, 5. Okay, so I have part out of the whole. I always want to do part out of the whole. And that's going to give me a decimal. And once I have a decimal, I can change it to a percent. Okay, so 2 is what percent of 10? So 2 is the part. 10 is the whole. So I have 2 out of 10. Now this one you can just change to a decimal, but you can always just take 2 divided by 10. Remember, fraction is just division, and you're going to get 0.2. Now we know that if I have a decimal and I want a percent, okay, so remember a whole is always out of 100%. How many zeros do I have? 2. So how many decimal places do I move? 2. So if I start with a decimal, remember a decimal always looks smaller. So I'm going to make it into a percent by moving it 2 places, which gives me a 20%. Okay, 8 is part out of 32. That gives me 0.25. I have the decimal, and again, you can just use your calculator. Take 8 divided by 32. So now I move my decimal 2 places, and I get 25%. Okay, good. And this next one, you're going to do the same way. Use a calculator. So 1.375 divided by 25, get a decimal, move the decimal point. Now the next thing we're going to talk about is percent change. A percent of change is a ratio that tells how much an amount can increase or decrease in relation to the original amount. If the original quantity is increased, then it's a percent increase. So that's where you just kind of use some logic. Did it get bigger? Then it's a percent increase. Did it get smaller? Then it's a percent decrease. And I'm going to change this a little bit. Percent increase is the amount of increase. How much did it change? Now, you're not going to have a negative number. Don't worry about negatives. We'll talk about that later. But you're going to take big number minus small number. That's going to be your change, amount of increase. And that's going to be divided by the original amount. Okay? That's all you have to do with this one. So here we go. Example A. A couch at a furniture store has a wholesale price of $850. It is marked up, so that's the new part. So is this an increase or a decrease? That's right, it's an increase. Now, what is the percent of markup? So we're going to take the biggest number, 925, minus the smaller number, 815, and then we're going to divide it by the original. What's the original price? What did it start at? That's right, it started at 815. So we get 110 over 815. And then we divide that, and I forgot to bring my calculator along with me. So you're going to take on your calculator, take 110 divided by 815. When you do that, you get 0.134969, blah, 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 blah. Well, you're not going to write all that, okay? We want a percent. A percent is 2 decimal places. So we know we're going to have to move this 2 places, right? So it's going to be 13 point. Let's round it to the nearest tenth. So it's going to be 13. Okay, look at that. That's what I'm rounding to. So I look at this number. If it's 5 or above, give it a shove. 4 below, let it go. That's right. I'm going to give it a shove. So 13.5% increase. Okay, that's all you have to do. Big minus small. Okay, so try this one right here, B. Try it on your own. Go. So you took the largest value minus the smallest, so 1118 minus 1050, divided by the original amount. Okay. So it talks about the sales tax percent. So I'm going to take big minus small divided by the whole thing. And on this one, you can see that the tax is actually just 68%. Okay, so on that one, that is your tax. So we're finding out the percent according to the original, and we get this lovely number. Now, of course, we're going to move our decimal point 2 places because we want a percent, and then we're going to round to this place right here. Wow, they're always going to be a 4. That's weird. They're not. So we get 6 point, round this off, so I'm going to give it a shove, 6.5%. Okay, you get the idea. Let's go to the next page. So percent increase and decrease are the same. The only difference is that you have to think for yourself, did it go up or did it go down? If it went down, then it's a decrease. You're still going to do the same thing though. You're going to take the big number minus the small number, and you're going to divide it by the original amount. Okay, so here we go. A pair of jeans sells for $95. You pay only $71.25. What was your percent of discount? Not was your discount. But you're going to start off by taking big minus small divided by the original, which was $95. Okay, a pair of jeans sell for $95. You pay only this amount, so it's obviously a discount. So this is a percent discount. Now you subtract. And you get $23.75 over 95, and you get 0.25. Okay, so now change that to a percent. I'm going to move 2 decimal places, so I get 25%. That was your percent of discount. Okay, so you can see percent increase and decrease are exactly the same. Now we're going to talk about the percent error, and we're going to find the amount of error. Okay, I'm just reading right here. Amount of error divided by the actual amount. Okay, amount of error, what do you think is going to happen? You're going to take big minus small again. But this time, not the original. It has to be, what is it actually going to be? What is the actual thing going to be? Okay, so here we go. You estimate the length of your desk to be 24 inches. That's your estimate. The length of the desk is actually 28. So now, what's the percent of error in your measurement? You're going to take big, 28, minus 24, over the actual. Big minus small, divided by actual. What was the actual? 28. So you're going to take 4 divided by 28. That's going to be a lovely decimal. Yep. You get 0.14285, blah, 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 blah. So, let's move our decimal point. 1, 2 places. We're going to round. So we're going to get 14.3%. They don't always round up. That's just a weird coincidence. Okay? Questions? Oh, wait. I'm not there with you, so if you have them, you might need to email. So as you can see, these are all kind of the same problems. It's all big minus small divided by either original or actual, depending on what you're finding. So what you're going to do for your practice, for your homework this time, is you're going to do 10, yes, exactly 10 IXL problems from 7M8. Show your work on the attached paper, the next page, the page that's stapled onto your packet. Okay, you're going to show your work. Now, if you're at home and you're absent, just put 10 problems on a piece of paper. Now you're going to complete these 4 problems, okay? So the first one, the crowd at a sporting event has estimated the exact attendance is this. What is the percent error? Okay, percent error, percent error, percent error. So that means what you're using is these problems right up here. I'm going to take big minus small, divide it by the actual, whoops, well that's a fun thing, divide it by the actual. It has to be actual, so pay attention to that, okay, and do those problems. That is what you're doing for homework. Great, and if you have any questions, you know where to find us. Thank you so much.